Hello, this is John Sprovieri, Chief Editor of Assembly, and welcome to our latest webinar, Cut, Scrap, and Prevent Rework, Smarter AI Inspection for Manufacturing. This event is sponsored by PICO. Wherever and however you are watching, thank you for making us a part of your day. Today's presenters are Brian Bao, Chief Operating Officer at PICO, and Russell Nibelink, co-founder of Overview AI. Now, this is a live program, folks, so please do submit questions for our speakers. Later in the program, we will address as many as possible. Today's event is being recorded and will be archived on our website, assemblymag.com. And now I will turn it over to today's presenters. Gentlemen, the floor is yours.
Thanks, John. We really appreciate it. We're glad to be back here with the Assembly Mag for another webinar. I'm excited to be joined by Russell and one of my favorite integrations, Overview AI. I think there's a lot of future here. So I hope everybody gets something out of today's webinar. We're going to cover a fair bit of ground in a short period of time, so feel free to ask questions, join in on the poll that we'll have in a little bit. And yeah, we'd love to make this as interactive as possible, make sure you get the most out of this. Let's dive in a little bit first, just to give a background of why we think this is an important conversation for folks to kind of jump in on as we move towards the connected space on the manufacturing floor. We polled everybody before the webinar to get a feel for what is the leading cause of scrap and rework on shop floors from y'all. Number one being operator performance or training gaps. And we'll dive in a little bit of what that looks like in a second. The second was process control and documentation problems. As being a recovering industrial engineer, I would actually say 1 and 2 probably overlap. It's just the lens at which you're looking through it. No pun intended, given we have a camera company on with us. The third being the incoming material or component variation. And then the last one being the integrations or the lack of feedback from the tools. And again, that actually might feed some of the first and second one, depending on how you've deployed your solution. What do you take out of this, Russell?
Yeah, I think that, there's not one size fits all when it comes to scrap and rework. We work with a lot of process engineers, and you're always trying to really understand, break it out into chunks and kind of optimize piece by piece. And I would definitely say that these 4 things are what comes up the most.
Yeah, it definitely feels like we're in the right space for today's conversation. Let's dive a little bit into some of the details before we get to our first poll question. Some of the challenges, at least from what we see on the PICO side, and I'd love to get a little bit on your insight there too, is like what we see from PICO side is a lot of folks come to us because PICO is both an MES plus an IoT platform. So we actually go over a lot more of the tech stack than a traditional MES. Is we actually see a lot of folks have issues with their data collection. We had one company come to us still on 3x5 index cards when they were doing manual on the paper. And so that's a really hard thing to keep up to date. It's really hard thing for people to enforce. And then you add in that QA function, which is where y'all take over some really cool technology capability to kind of where your operator is integrating with both the process and the inspection, particularly in more regulated environments. A lot of those challenges come forward. I mean, if you want to talk to the right side there of what you see as the inspect challenges.
Yeah, I think that kind of in our industry, it's pretty well established that, a human operator inspecting a part with clear instructions is usually going to miss 20% of the defects over a large sample set. And that's just because, people get sick. They are tired. There's the night shift. And so, even if you have, clear instructions and easy inspection, the human is just not wired to be perfect every time. Whereas even for simple things with, an automated solution, you can kind of guarantee consistency in your results 100% of the time through, whether the camera never gets sick. And so this is why even in very manual processes, you still have these challenges with errors and rework that's required because, you tell the operator to do something and then you ask them to check it, and that checking part or you tell someone else to check it is not infallible just because humans, are going to have those issues. Yeah.
It's fascinating having run a number of manufacturing operations. That is a very interesting. You have a person sitting there for 2 hours at a time because they get a break every 15 minutes or plus their lunch break. And you think about it, they're pretty much doing the same cognitive burden as a lifeguard who has to, by law, change out every 10 to 15 minutes because that cognitive timing is you have to give somebody a break. Otherwise, they just kind of slowly tune out. And that's the same thing as what you're talking about. That's why it's so interesting to kind of capture that data along the way. I'd love to get some of y'all's feedback. We have a first poll question along with the lines of what we were just talking about. Is how do you run your inspections? Is it all manual? Do you do some level of automated vision system? Do you have semi-automated systems that work with the operator? Is it sample? Is it 100% inspection? Or do you not inspect? I'd love to get some of y'all's feedback out there in the space so we can kind of talk to some of that. I see some of our first answers are coming in. When people call you in, Russell, where on the spectrum do they tend to lie from your customer base of those?
That's a great question. I would say that in terms of the number of applications, it's usually people who have very manual inspections and they want different stations to inspect it. But then in terms of kind of the volume of cameras, it usually comes from already pretty automated facilities who want that extra edge to like improve their quality a lot more, like maybe like that last 1 or 2%. And so we definitely see both sides of the spectrum. People who are starting on their journey of automation and people who have very highly automated facilities.
What's the driver for someone to bring your company in either of those situations?
Yeah, I would say there's a few main drivers. One is like preventing recalls. So if you can, if you're an automotive company or you're a medical device company, like you don't want recalls because that is reputationally damaging and very, very expensive. But if you're a manually, like a lot of human inspectors, you can also save a lot on your operating expenses by bringing in cameras. And especially with how difficult it is to hire today in these manufacturing environments, that allows you to kind of reshift a lot of these workers and operators into production roles instead of inspection roles. And that helps a lot with efficiency. So, those are kind of a few of the main drivers of why people, decide to bring in automated inspection, improve efficiency and improve quality.
It's definitely a needed space. I think it's probably more needed than a lot of people does because there's a lot of hidden cost in the rework, a lot of hidden cost in downstream activities, whether it's in the site or the kind of 10x theory of it. Once it gets out to the customer, it goes up by multiple once it reaches out. All right, let's jump over and see how our polling results have come along so far. So we're pretty much split between manual inspection and semi-automated inspection at the moment. I know there will be more updates to this as this gets posted out on demand afterwards. But at the moment, we have about 4% of folks that are sitting at a fully automated system, and then the rest of them are somewhere sitting behind it. The positive is nobody's not doing any inspections in the bottom bucket right now, so we got a 0% on that. So maybe that's just a sampling because people want to come talk about inspection for this webinar. What do you take away from that, Russell?
I think that, this is kind of, I would say, in line with the industry we're seeing. I think that people are at this webinar because they understand the value of AI and what it can bring to not just the factory at large, but specifically this problem of inspecting your parts. And then the first step in that journey would be something semi-automated, right? Assisted inspection, because that's going to be a lot easier to implement than a fully automated system. And so I think these results seem in line with what I would expect kind of in the industry landscape today.
I love that. I'm going to double click on the term you said there, AI. A lot of folks come to us because we're a big platform, shop floor execution, MES plus all the other stuff, ask how AI gets implemented. And away from the front office where you have the generative AI stuff for procurement and finances, stuff like that, where you just landed is the first part I always go. So people ask me, where do I put AI on the shop floor? The first thing is how do you integrate that into your inspection protocols? Because that is probably the biggest impact somebody could have from an AI point of view. I'm kind of leading the horse onto our next slide anyway, but I would love you to kind of talk to kind of how the evolution of automated and semi-automated inspection is coming along here, and then just kind of walk us through where the kind of next steps are going for, so people can realize how actually simple it is and effective and almost commoditized it is.
Yeah, I would say that based on, for the last 20, 30 years, we've had these rule-based systems that have been extremely useful. And now with kind of the advent of AI, it's really a paradigm shift in how you solve a problem. In a rule-based system, you're thinking algorithmically. You're thinking based on a set of rules that define criteria. With AI, you're thinking very data-centrically. So what is the data, and in this case, the images that I'm going to need to label to then have the AI system perform? This is actually a lot simpler because anyone can look at an image and understand if something's correct or incorrect, or what the criteria are, and then label it. And so this has really lowered the barrier to entry from what you used to need is like a specialized vision engineer, and now it can be really anyone. And then what you can do is actually increase a lot because it's easier to model through data than it is rules when it comes to, for example, in this case, there's a screw that's fallen into a part. A screw can be anywhere. It can be hidden. But as a human, it's very, very simple to see it and label it. And then that's now the job of the AI to translate the human's opinion into a production system, which can be location invariant, size invariant, and it can be, handle occlusion. And so that's really opened up the gates to a lot of practical applications.
Yeah, I love it. And again, coming back to the discussions I have around AI, a lot of folks are trying to get AI to displace human capability. And I think where AI is really accelerating is where it augments human capability in the decision points. So to your point, instead of following a very prescriptive set of rules, following a more of a decision database matrix, you can actually give people the opportunity to say, I can actually go tighten this, or based on the data I'm getting, I can loosen this because it's not causing issues. And it kind of takes you in a more robust product path, as opposed to just forcing you down a set of guidelines down that way may be out of date or may not actually be applicable to where your product needs to go. Why don't you talk to us a little bit about how Overview dives in and tackles some of this going forward?
Well, I wanted to kind of double click on one of your points you made about the data, right? Not just using AI to automate your inspections, but now you get an image from every single part that you're inspecting or process that you're inspecting, which you can send to a place like PICO MES for traceability, for root cause analysis, and for process improvement. And so that really allows your engineers to have better image data, better analytical data from the inspections to do a better job, to ultimately not just find the problems, but then fix the problems long term. And that's a huge advantage in just building a better factory. Sorry,
I love that. We actually internally want to call ourselves a continuous improvement tool, but that's not a very good marketing name.
but it's valid, especially with the advent of AI. You can also you can get more insights than ever on that type of data as well.
Yeah, augment the leadership, augment the team that's actually going and doing root causes. And then, to be fair, and where this slide's kept starting to go, is that technology is not inaccessible. When we first deployed a solution similar to yours in 2016 at a aircraft brake system, there were, I want to say, 6 cameras. Someone will correct me when this gets posted. Taking pictures is taking about 60 different data points, and it still took a lot of human interaction with that because the AI function wasn't there to go through and do the learning, so it was a lot slower. It also took about 18 months to deploy. These days, you're going to tell me that's a lot faster.
That's true. Yeah, I think relative to this slide, and also kind of touching on what we talked about earlier, like the barrier to entry has lowered a lot. It's much faster to set up. The algorithms and the AI models are so powerful that you need a lot less samples. And what I tell our users, the people that we help, is today, if you can see a problem or something on the factory line or on your product that you can see it from the perspective of a camera, or in this case, our cameras, we can inspect it. And whether that's cosmetic, whether that's assembly verification, whether that's a black on black scratch or a shiny thing, as long as you can see it, or counting, or flow process analysis, as long as you can see it from the camera, it's now doable to automate it, inspect it, and then get a really rich data source out of it with near 100% accuracy. And I think that kind of frame of mind really opens up a lot of options. And so it's kind of a new way to think about, engineering or process engineering at your factory.
Yeah, I love it. And in line with a lot of the points made on your slide here, it gets you to a condition where you can get your return on investment, both for the finance and the senior management, quite fast, because it's set up quickly. It's actually flexible. But also that simplification of the implementation side, the cultural adoption happens a lot quicker too. So the folks that are on the shop floor, the folks that are helping set up the shop floor, will take to it a lot quicker because it's not as frustrating a learning curve to get it up and running. So the systems we used in the past, a decade plus ago, took months to get up and running. It took lots of time. Everybody was very back and forth. How do we solve these nuanced problems? And with the capabilities in and around both the hardware and your software to go implement in flexible situations, I think is where it really takes a lot of people forward and can probably deploy in a lot more spaces than they even think they can.
Absolutely. And yeah, what I like to say is, like, if someone can see the magic within a couple hours, it's going to be a lot more motivating on the shop floor to implement it and to continue, that final integration piece, rather than them feeling like it's a frustrating experience. They can feel like it's an enabling thing that's going to really help them and their operations. So, that's we try to design and build products around that, getting to that aha magic moment as fast as possible.
That magic moment. Yeah. Love it. Any of these features really kind of want to stand out when we do talk for the audience?
No, I think they're all kind of in line with, like, helping see the problems from the perspective of the camera, right? It's not a magical camera. If you need the right lighting, the right lens, the right angle, that's purely so the person can see the problems from the perspective of the camera, and then they can label them, and then we can detect them. So these are kind of all in line with that philosophy.
Yeah, simplifies the tooling and the setup and everything else. I mean, like I said, that big brake assembly used to do had a massive jig I had to go into for these cameras to get honed in exactly where they need to be taking those pictures to look for the deviations, what they needed to do. So you go from the camera, and then where you talked about a minute ago, Russell, is what do you now do with some of that data? And where PICO's kind of tech stack will help bring that in is you can pair that with the work instructions and you can pair that with the traceability. And it really does drive the continuous improvement side of it. So you can both do the smart stuff that Overview does, which is actually go in and read the part and find if there's any errors away from it. And then you can actually do something that feels simple, but it's actually quite powerful, which is just take a static image. We used to have some aerospace parts that would go into Boeing planes, and we were always arguing over the finish quality, whether it showed up dinged or damaged. And we had one QA that literally sat at the end of the line with a camera, but they had to go back and tie those pictures back into the part number at the end. So half of his day was always spent trying to figure out where those parts were and relabel all those pictures. When you use something like Overview's camera sitting over the top of the system with PICO, that part automatically gets logged to the serial or to the traceability aspects of it. And so the simplification of setting that up actually really moves forward what somebody can do as a QA or a quality inspector on the way past. So that's why I really love working with Overview on that. So if I dive into the next slide that kind of talks about that data, what we effectively do from PICO's point of view, as you can see there, is you have all the traceability data and efficiency data, but within there is that QA image, and that's the image that's stored, and you can pull that right back out, time, serial number. You can actually understand when those are doing if you're trying to do it on a monthly basis to see trends. And then more importantly is there's the output report from the Overview camera that we actually pull right in. And so Overview does track what it's taking, but we then take it one step further and link it back to all the other data that is coming in against those parts. And so it gives you a full build record. And like in aerospace or med devices, you can then create effectively a traceability pack or download a build pack that gives you all of that linked back to the specific part we're talking about. And it's really quite powerful combination on the top of that. If I move on, I mean, we got a simplified slide here that takes us in the overview. I can use overview and overview A. Takes us to kind of the full traceability package that comes along with it. But when we start talking about error proofing, having that data at your fingertips, and where you went, Russell, is with the real-time tracking and the real-time quality improvements. When I used to run factories, we would do what they call Kaizen events, which is go out and try and figure out where to move the ball forward next on our production. And the first half of that was collecting data. We'd go out and take pictures, we'd go out and do time studies, things like that. With something like Overview, and then PICO's in the background linking that, you'd have that data already there, and it pretty much would direct you where to go to solve the problem. That. What do you see from your customer base as far as driving improvements?
Yeah, I mean, absolutely. So a lot of the quality teams will generate Pareto charts, basically stack ranking the types of defects and finding the highest frequency types of defects. And what's cool about the Overview system is it's not just a binary pass fail, but you can actually break it out into many classes of defects. It could be, I mean, let's say for a damaged piece of plastic, you could have missing plastic, you could have a bump, a dent, a scratch, and then understanding where on the part those are, as well as what type of defect they are, really allows when for example, when you do a Kaizen event to just pick off the top of the thing, like 50% of our defects are this, like we should focus on that first. The next, then 20% are this, like that can be the next thing that you plug off the list. And that's only doable because they actually have that record and each inspection, which they can then trust to kind of create these Pareto charts.
And how much effort is it to train your camera to go look for those kind of defects?
Yeah, I mean, it can be as simple as three to five images per defect type, and so it can happen very, very fast.
Yeah, I love that. And I'm all about speed and commoditization of this technology so people can get it on the shop floor. We have a case study here that kind of talks to that. I'm implementing PICO, rolling it out. So getting up and running with a few stations. We had one company come in and drop a few 6 stations in there. They were introducing some robot integrations. They then dropped in the Overview camera. And within the year, they had over 20 connected stations and 100 connected devices. My mind is boggled by that, having run factories, to be able to get from what is effectively Industry 4.0 or 2.0 to Industry 4.0 in about 8 months to 10 months is a vastly different game changer. And when we start talking about how you become more competitive and how you become, well, all the other things that are going on in the greater picture around reshoring, it makes you a much more robust company to go tackle new business, if nothing else. So I think really where we want to land this plane before we take some questions is what's the roadmap? Where do people go from here? So when they bring in Overview, what are the kind of key points that they need to do, and where do they start the journey?
Yeah, I think that the best way to start is really to find what's the most expensive quality issue they have. And usually there's not just one, like there might be, a handful. And then, we work with them to basically identify what's going to be the fastest to set up the camera, to get good results, and to get the fastest ROI to create a win, right? We want people to start with one and get a win as fast as possible. A win in terms of implementation, in terms of results, and then in terms of payback. And then once you have that, it makes, scaling it up or like adding new things much easier because we already have that win and you have the trust factor from the large organization.
What's the fastest somebody's rolled out how many ever cameras at a facility for you?
So that's a good question. For some of the manual stations, we've actually been able to come in with the stand and get them doing assembly verification within a day. Now there's a trail end. So like, are we integrating with all of their factory systems and MESs within that same day? Usually no, there's some IT stuff, but in terms of like getting the inspection, it can happen, within a day, at the short end. And then of course, if you have like a highly automated system, or you need to put it on the end of a robot, there's going to be more complexity there. But we're talking usually in the order of days, maybe single week, rather than months.
Yeah.
And so it really is kind of an order of magnitude faster than it used to be.
I love it. And to be fair, looking at the path, both what you just described and the case study we had in the previous slide, is you can come at it either direction. You can start with the camera to tackle the quality data, or you can start with the traceability package of PICO and bring the camera in either. And it doesn't make either one's not harder. They're both just as quick to effect to deploy across there. And so both of our teams lean in, and they're pretty quite integrated and helping. I'm going to wrap this up here so we can get to some of the questions. But if you have any questions from us that are offline or want to know more, we have some links for you here on Next Steps. You can reach out to Russell and the team there at the Overview AI email address. We also have free instructions available on PICO. You can go access on the cloud for free. I am going to give a little shout out. We have another webinar coming up on how to import work instructions coming up here in a week or so. So feel free to jump on that. And then for those of you that want to kind of start your traceability journey, we've made a little checklist of things that you can go out and integrate with. But with that, hand back to John to tackle some of the questions that have come in.
Excellent. Excellent. Thanks, gentlemen. This was super interesting technology. So before we take questions, I would just like to remind everybody that we would like your feedback. So please do take our survey after the webinar. All right, let's get to our first question here. Marcy asks, this level of digital traceability would seem to help with CMMC compliance. Does it help with reporting and compliance? Not sure what CMMC is. Maybe Marcy, maybe you gentlemen know that one? Or?
CMMC is one of the more regulated environment requirements along kind of the ITAR, SOC 2 compliance, things along those lines. So CMMC, yes, this reporting would very much help you along that. It would get you the data. It effectively proves out your process as opposed to the old manual ways of collecting a lot of that data. So the combination of Overview and PICO will definitely jump you forward in CMMC compliance.
All right. Here's a question from Connor. If the system is capable of finding defects and non-conforming features on a part, how does this reduce scrap or rework? If the defect still exists, regardless, would the camera system only reduce the number of escapes?
That's a good question. Oftentimes we're putting cameras in line. So for assembly verification, if you can catch it at the end of a station that's supposed to do a certain task on the assembly side, then then you can fix it immediately rather than putting the cover on the engine and then putting the engine in the car and then it getting all the way to the end of the production line. And then suddenly they do a test, they realize there's an issue. They have to basically undo the entire assembly of, the car to get to that thing and fix it. And so instead of being a 30-second fix, it becomes a 2-hour fix. And so it definitely, if you do end of line, I completely agree. If you're putting cameras in line into the process, you can greatly reduce the amount of rework you need to do. And I'm using a car as an example, but you can imagine that for any sort of assembly process. You can kind of catch it earlier, fix it faster.
Yeah, and I think too, as you pointed out too, this technology categorizes the defects, and you get Pareto charts, and you can figure out what your common mistakes are, and then work on preventing them. So there is a certain amount of feedback into the process, right?
Mm-hmm. Absolutely, yeah.
Yeah, and getting a continuous improvement process, the earlier you can identify the issue, the easier it is to find the root cause and to solve it. And so to Russell's point, if you can put this in line, you can find out it came from the step before you, as opposed to if it gets to the end of your line or even to your customer, trying to identify that root cause, you'll have a lot of other products built up behind it that could have the same issue. And B, you actually have to go back and check a lot more parts of your process to see where that problem was starting.
Right, right. All right, super quick here. Everybody's got concerns about AI. Russell, how secure are the overview cameras?
Great question. They're extremely secure. The data never leaves the environment of the camera locally unless you specifically send it to where you want to go. And for example, to Pico MES, we're working with them, with the customer to send it specifically to them, but it never actually leaves and goes to our servers, right? All of the processing is happening at the edge on the device itself, unless specifically requested and set up by the customer on the camera to somewhere else. And that's kind of why we're able to be used in aerospace and aero defense. Customers like SpaceX, who obviously can't have any of that data leaving their air-gapped
Right.
environment.
Yeah,
Right.
Pico down the same rabbit hole. We actually run on-prem. So if you want to do an air gapped, you just take the analytics server that is the cloud and push that back down. But our whole server is only connected to the cloud through one VPN if you do a cloud implementation. So we can do air gapped or ITAR capable facilities also.
All right. All right. Well, I'm sorry to say that is all the time we have for questions today. Please join me in thanking Brian and Russell for their presentation, as well as our sponsor, Pico. If you have additional questions or comments, please click the emails button on the console, and please visit assemblymag.com/webinars to see the recording of this presentation and to get information about our upcoming events. We've got a slew of recorded webinars that you can watch on demand. So if you thought this one was good, check out our previous ones as well. So that's all I've got, folks. So until then, keep after it.